We are going to start the session 3, and I would like to present to the first speaker, Jose Juan Alarcón. He's going to talk about the farm ways, integrating water reuse technologies and digital tools for circular agriculture research management. Please, Jose Juan. He works in the Water and Plant Production Department from Cebas in Murcia.
Well, good morning, everybody. So the main objective of this presentation is to explain that we are doing in one European project, farm-wise project. I don't know if you listen to me. It's okay. The title of the project is Future Agricultural Resource Management in Water Innovation for a Sustainable Europe. It's a project, in this project, it's one European project from Horizon Europe. There are 20 partners for 12 different countries. The budget is about 6 million euros. It's a project of 3 years. And the objective of the project is to develop some innovations and approach in order to develop the agricultural water sustainability topic related with precision agriculture or circular water management. Okay, obviously the one problem that we have in the world, in Europe, and especially in the Mediterranean area is, we have different problems in the agricultural production. The first one maybe is the water scarcity. It's not necessary to explain too much, but you know that, especially in some areas, like for instance in Murcia, that is where we are working, the amount of water that is for the agriculture is very low, and you must know also that the agriculture, as you know, consume about the 80% of the total amount of water that we use. This is because the climate pressure, the climate change increase the temperature, decrease the precipitation, and in general increase the level of evapotranspiration and the level of water quantity that the plant needs to grow. And another problem that we have is that we need to use non-conventional water, the saline water normally. This saline water normally must be treated. Saline water can be reclaimed water, must be treated. And the result of the treatment is sometimes the brines. And this brines is something that is not very easy to manage. It's something that we must know how it's possible to manage, especially in areas that is not close to the coast. The brines from the desalinization close to the coast normally it's going to the sea, but it's inside the problem is higher. So considering these three big problems, in the project we apply 3 different approaches. The first that we test in our experiments, in our farm, is the use of different alternative water sources to produce. The other approach that we are testing is the development and application on one decision support system in order to improve the water use efficiency in the crop production. And the other solution that we are proposing is one system that is called EvaCol system that suppose one new way to treat this, the brines in order to obtain, to recover the most of the amount water that is possible. Well, this is these 3 approaches we tested in one farm that is in Torre Pacheco in Murcia. Obviously, the climate condition in Murcia, as you see, is semi-arid conditions with a level of precipitation close to, for lower of 300 millimeters. And we test this different approach in 2 crops, in orange and mandarin. Here also you can see the system when we are applying this decision support system to improve the irrigation water supply, and also the EvaCol system. These 2 elements are are developments from different companies that are involved also in the project. Well, this is more or less is explaining. So in relation with the alternative water sources to test different non-conventional water, we have three different treatments. One treatment, control treatment, and we apply, in this case, conventional high-quality irrigation water with one electrical conductivity close to 1. Also, desalinated groundwater obtained by reverse osmosis. In this case, the final electrical conductivity also is close to 1, is good. And also, we are using reclaimed water. In this case, was not very solid water, but it's about 1.5. So the idea was to test, to use these three different water quality for irrigation and to see if there is some effect on the growth or in the physiological response of the plants. Well, basically, I don't know. Basically, there is not effect. In fact, the three levels of electrical conductivity was very similar, and the experiment is only 2 years, so maybe it's not time enough to see if there is some effect. Maybe with the long time, maybe see, but by the moment, it's not big difference. Well, this is one example of some physiological response. Here, leaf water potential, stomatal conductance. Well, the most important things, in one case is orange, in other case mandarin. The most important thing is that the evolution of the different treatments of all these physiological parameters are very similar for all the treatments. In relation with the application or this decision support system that were developed by one company, the name of the company was Nutricontrol, it's also established in Murcia, was a very important reduction of the amount of water that we apply respect to the one conventional irrigation system, about one reduction of 12%. Of course, this reduction of water supply maybe suppose some reduction also in the level, in the level of fertilizers that we are applying. At the end, this reduction don't suppose a reduction in prot. The reduction in water and fertilizer was not a problem to maintain the crop, the yield, and also the crop physiology. Well, this is some data. Maybe the most relevant is this irrigation KPI. This irrigation KPI is established like the ratio between water amount that we put in the irrigation and evapotranspiration. And you can see that when we apply the iris system, this KPI decrease. So for the same evapotranspiration level, there is a reduction in the level, in the amount of the water that we apply, about 12%. And finally, the other approach that we are testing is this system that I told you. I told you previously. The name is Evacol, and in this case, they use they take the brine and they treat this brine with one system of forced evaporation that the final result is to obtain one recovery of water, about 188% of recovery of water. So we, in the experiments, we managed about 192 cubic meters of brine. After the application of this system, we obtained 180 cubic meters of water recovery. The quality of this water recovery was very good. And besides, this system is, it's not energetic, has not a very energetic, it's good in an energetic way, and it's also good in order to the economical cost reduction. So, basically, this is the three things that the three approach that we are talking about. And the idea is to apply it in the framework of one circular declaration. You can see that there is not one unique solution. There are three or more different solutions, and this holistic approach in order to increase the water agricultural sustainability in areas like the Mediterranean area is that we are trying to propose in this project and in general in our group. Thank you very much. So.